Well, hello. Welcome back to the stream. I'm Jun-chan. And yeah, it took me a while to get back into a working condition here. So basically, I updated my NixOS install and really moved forward just a few minor or like patch versions on the kernel. But I don't know if that's it or some of the other configuration that I done with virtualization, but my my OBS wouldn't encode properly. But I think we're back into working order now. So let's just start the world. And yeah, so we have GNOME 4. Hey, Freddy Lachance, thanks a lot for the follow. Really appreciate it. And I'm going to connect here. You know what? I think you're the 50th follower. And I think that means that we have a new Twitch achievement. So thanks a lot for that. Really appreciate it. Let me go take a look at it. Let's look at it together. Get 50 followers. Yeah, look at that. Recently completed. What is thy bidding? Followers can opt in to be notified when you stream or share an update. How about that? Hold on. But this says reach 50 followers 49. So, So build a community. Maybe that's not updated yet. You know. It really just happened, and that might be recalculated recently, or rather not as often. But where is that follower count? Insights, channel analytics. Yeah, not clear. Well, so that's where we are at. Freddy, thanks a lot for the follow. Really appreciated that. And yes, so what are we doing today? Where we're starting our Visual Studio Code as usual. And look at that, it just starts exactly where I left it, which is not how it was just before I upgraded to GNOME 4 and started to do a little bit of keyboard mapping and you know, making things just a tiny bit better. I was able to put Chrome in the taskbar, but I can't put OBS in the taskbar. Not sure exactly why yet. But what are we going to do today? Well, we're going to do graph Comonads again. So that's what we were doing last time. So let's do our little housekeeping there and start a new log for the day. And what did we do last time? Well, we started to implement or look at implementing the graph Comonad for Purescript Alga. Alga is our algebraic graph, so it's the algebraic graph library that's inspired from the library of the same name in Haskell. And we were poking at it, and we started by writing a couple of basic tests. So let's just refresh our memory and see where that leads us. So Alga is here, and yes, we trust this. Okay, and what did you write as tests? Well, we have a few things that are at log, but we are able to make a Singleton Graph by doing just Vertex unit. That's a library convenience constructor. And we see that that's equal to unit with no array, with no edges. And this graph over unit is a bit of a strange graph, because basically we're defining graph over keys, and so the graph over unit really has only two possible states. It has either well, maybe three actually. It's either empty, or it has a unit vertex, or it has a unique vertex with an edge. So that's sort of what we have here. Let's make the empty graph as well, actually. How about that? Make I think we're supposed to be able to do that with empty. Maybe it will matter that we're doing this in graph unit, and in that case I expect to have an empty list. Let's try that. We want to go into libraries and Purescript Alga and Spago test. That fails to build. Oh yeah, that's because we started on some larger refactor or works on stuff. So let's see. Maybe we can stash some of that stuff. How about algebra? This guy we might not need to stash. Or except, yeah, I started working on focus graph on there, but we should be able to manage that. So let's just stash this. I think dash dash. We need to stash untracked files. So that's -u. And then we Spago test again. Yes, except we haven't saved this. So let's try our empty graph. And okay, oh, right, what? Okay, I see. Is that what happened? What? I'm a little bit confused right now. Oh yeah, that's because I haven't mapped all the things and make a singleton graph. Yes, so I'm definitely hold on. Definitely need to do this, and then this, and then this. Okay. And I need to map my keyboard shortcut for Control Z, because that's going to be annoying. Undo, undo, and there we go. Since I've started remapping the world so that my macOS muscle memory wouldn't that wouldn't have to context switch all the time. Really costly to do that for my poor brain. Yay, we can make an empty graph. It totally does work. Actually, I think we probably didn't even need to type it. Oh, we did need to type it. Good instinct. Excellent. Yeah, I'm going to have to map redo as well. Redo shall be this. Okay, and redo and undo. There we go. Excellent. So we have more tests, and let's continue a bit. So if we overlay two vertex unit graphs, which are really we overlaying the same node here over itself, then we actually have the same thing as the singleton graph. If we add an edge to that unit graph, well, let's call it a unit graph. That's a singleton unit graph, an edge. In the unit graph, and then we connected to singleton graph, which gives us, instead of if we just connect two nodes in the graph unit that are actually, because they're the same, because there's only one single node, then it just gives us back that tuple unit, but with empty edges, because we don't have edges. Whereas if we connect those two things, then we create an edge between it to itself, and so we have a unit edge in there. Same thing that if we create an edge between those two with the edge constructor. Okay, so let's continue just for a second with shall we categorize these things? Maybe we should. Let's get back to Purescript spec. It was right there, and maybe this, and let's do describe, right? And here and here, and then describe again, and then we say car graph char. It that's probably fine. Graph unit, and yeah, I suppose empty graph char should also work, right? And however, a singleton char graph could be something like vertex A, and that should give us an A here. Ain't that right? We need to import describe from our tests thingies, and Purescript ID tells us it's from test spec, and that seems to be the case. And we have test passing. Okay, and so now let's do our ABF. So we're trying to do, yeah, right, we were trying to reproduce the graph from the blog post that is inspiring all of this graph Comonad series, which is this specific graph. And yeah, I wasn't sure whether I was succeeding or not. Wasn't clear about whether I understood the meaning of circuit properly. Because, yes, no, we were. That's it. We were, but they were directed graphs, and circuit was building a directed graph between ABF. And so when we were listing edges from it, we only had the output edges, basically. And so I think, at least for whichever from array, whichever adjacency list we were using, which, by the way, maybe is a little bit arbitrary there, that for the default case we return a we don't return incoming or differentiates incoming and outgoing edges. It's a convention, but maybe it should be at least documented. Adjacency, I think, yeah, it should be somewhere here. Adjacency list, yes, it's to adjacency map, and then it uses the adjacency map list, adjacency map adjacency list function, which is this one, which uses the to unfoldable instance of the adjacency map. Let's just check our adjacency map. Single edge, but is it a single outgoing edge? Because with what we stashed, we have a whole bunch of equivalent functions, but for undirected graphs. But I think we need to figure that out a bit. So maybe we add a test for adjacency map. I think that kind of makes sense. In fact, arguably, it's a lower building block. So I think conventionally, we might even want to have this around here. And yeah, except that we're importing agency list from algebra.graph. So we might want to start making import explicits here, and at least have then algebra agency map as AM, and then try out AM agency map and see what we can do with it. Agency list. It will take an agency map, and can we construct one from? It's just AM wrapping a map. Wrapping a map of what to what? Where's the type of this? A map of sets, yes. And so by convention, do we mean outgoing edges? Let's see whether that's documented in the Haskell library. Alga agency map, or maybe even graph, to be honest, because we have agency. It's not easy to write. List, sorted agency list of a graph, blah blah blah. Good consumer, whatever that means. Okay, so maybe not. And then sorted agency list of the graph again. So okay, well, let's figure it out for ourselves. What we'll do is we'll have maybe a graph over Boolean with true going to false and false going to true, and then we'll see where those edges are attached. How about that? And in that case, we can, yeah, maybe we'll just use AM of map bool set of bool. Should we do that though? I think I'll first create the graphs and see where that takes us. So let's describe graph Boolean. I suppose arguably it should be here. And let's bypass the, let's just do the builds a simple cycle. Do agency list. The fact that we do agency list here, yeah, well, I suppose it means we are testing agency list all the time. So what did I say I would try? I would try to say connect vertex true to vertex false, and I would like to overlay that with connect vertex false to vertex true. And well, I'd say, what do we think that that should be equal to? I think we say well, it should be two tuples, and I think we're saying that from true it just goes to false, I think, and then from false it just goes to true. I think that's my intuition. Yeah, that would be true, but that's why we import qualified. Are you saying Come on, save. And adjacency map here, we're, well, okay, should probably be equal to that. But here we can say, I think adjacency map actually has, yeah, we can create vertices and things directly from here too. Yes, so I suppose we need to do something like that. Indeed we do. But apparently it's not exported. I mean, we can just get it from internal, I suppose, but otherwise it is not. Oh, of course, because it's adjacency map. Okay, so hold on, let's double check that it is exported from here. It is actually just re-exported, and I suppose I need to call it correctly. Adjacency map. And indeed we do mean am.empty here. Not m. All right. And we don't exactly have what we expected here. Well, we do. It's just reversed, so that's fine actually. That is fine. So I believe. Oh, I forgot to shortcut cut apparently. Cut. And cut. And the test pass. Okay, so I suppose we should be able to make this exact same thing with the adjacency list. So let's try and do that here with am.adjacency list and am.connect. So we'll am.overlay. And the rest should be fine. Indeed it is. Okay, but I think I don't want to make an adjacency list quite yet. I kind of want to introspect the map itself. So I want to, how do I do that? I need to, there's a new type. Yeah, there's a new type. So I can unwrap it and then use the show instance from map. How about that? And so we'll unwrap from new type. And we say that that's equal to empty string. And we'll see what that, how that tells us we're wrong. And well, yes, of course, we say we'll use the show instance for that. Okay, I suppose I need some added, yeah, parents, and there we go. So indeed. So we just need to understand edge as a directed edge creation, and I suppose that maybe that's what we need to look at here. If we see adjacency map, edge constructs a graph comprising of a single edge. It just doesn't say that it's directed. I suppose, or I suppose maybe that's just the assumption. But because we are somewhat able to document things as we like, here we can very well say directed edge. And I believe that makes the world just a tiny bit better. And then when we say edges here, there is a implicit direction. Okay, so let's just map this to the actual map. So let's unwrap and then create a map. That will have, right, we'll have what? You will have two keys. Maybe I should create it from foldable. That I suppose would take a tuple of A and a set. Dot dot what? Dot oh yeah, a well, singleton indeed. Singleton true, or was it? It's true first, yes. So let's say false, and assume that we are right here. Who knows? Who knows? So we unwrap, but we need only one. Is that? No. Unwrap, blah. And blah. Could not much. Oh. Oh, did I import set from non-empty set? I did. And that seems to work. And that actually also tests correctly. Nice. Okay. So let's just move, let's just, it makes the example graph from Comonad of graph decompositions. And that would be, well, it's the directed graph. So let's say makes a directed version of, for now, and we'll make the real thing hopefully by the end of the stream. Maybe. Okay. That should be undirected graph. Is that a quiver? Quiver is the name of the Scala library that Runar describes, and the quiver instruction empties the empty graph, and then we have the context, but multigraph A multigraph for quiver G. Oh, it's a directed multigraph. Okay. And ours isn't a multigraph yet. Because we'll need labeled edges, and right now we don't even have labeled nodes. I mean, I think, well, I suppose this counts maybe as a label. I don't know if the key can really be seen as being the label. It's not completely obvious to me, actually. Yeah, I don't know if that's needed that much. And right, this thing, so yeah. Okay, I'll just cut it, do the same overlay trick here, infix overlay, and paste, and we'll make a test with it, like a consistency list as usual, and we'll say that that should equal that's not the undirected one, that's the directed one. And we say it's equal to tuple a from array. So we say ABF with directed graph with directed edges, blah blah blah. So A only points to B, B only points to F, F only points to A. So except, yeah, no, that's right. A only points to B, but B, and that's a char, but B IPD points both to F and to C. Because when we overlay, B points to F on the left, and then when we overlay it to this path here, B points to C. So B now points to both F and C. And then C points to only D. That's just the way things are. And oh yeah, that's it's not the bracket I'm looking for. And D points to E in virtue of path, and that's it. And E actually doesn't point to anything, right? And that's a list. And that's parents. And then we just need to be patient and copy that for now. And apparently we've re-added agents and CDs here, which we shouldn't. And now we can get rid of our logs and make things pretty. However, from array ABF doesn't match lists, and well, that's because probably of this. And we need to do the same right there. Okay. And okay, so we have a different sign right here. So we have tuple A to B, that's fine. And then tuple B to F and C. So there's just the fact that F is first here. Right, so no, it's F is not first, right? So it's actually C and F is the proper order. Okay. And then D, and then E, and then nothing. Yep, that sounds correct. Not. F. Oh yeah, forget F. Okay. Forget F. F points back to A. F points back to A. Oh yeah. Okay, so now what I want to end up with my whatever is going to be, you know, undirected or UG.circuit, right? I'm going to want to import undirected graph from array. I think it's going to be fine. Overlay is going to be also from undirected graph. So we'll path. And then probably also the adjacency list. And then we'll want that to be equal to what? We want A to actually be connected to B and F. B to F and C, that's fine. C to D, that's fine. D to E, and that's fine, but also E to D, and also F to D and A, or A and D. So that's our test here. Except we don't yet have a UG, but we have stashed it. So let's pop it, and let's see where we're at. We want to say something like undirected as UG, and probably, well, at this point we don't even need to import. Yeah, that's it. Okay, great. Except that this doesn't build yet, does it? So let's spec go build and see what we can still need to do. Unknown data constructor vertex. That is not what I want to do. Okay, so apparently I've mapped this in a weird way. Terminal. Focus find. Is that what's going on? Alt F, focus on terminal view. Yeah. Yeah, no, just delete that, please. Reset. Thank you. And then find. Maybe Alt F. And we need vertex. Okay, so those things are supposed to be imported from where? G.graph, should they be G.blah? Let's see how, I think we've copied what Arga is doing here, and we probably have things open for undirected, yes, and so vertex, oh no, no. Vertex in the types, like for instance here for the applicative, no types yet. Still no types. No types here apparently. Okay, so it's just because we have these instances. No, empty. So how does empty work? Chorus GMT. I see. So we can just say UG UG GMT, no? UG GMT, I think. UG GMT. And then UG G vertex. How does that work? Yeah, it works pretty well. So let's do it. G.overlay. Yeah, that's the last thing we did last time. We didn't have a to graph, and to graph, I think, whoopsie, has a bit more involved. To graph was in from undirected, which was really yeah, here, and to graph is something we haven't done yet, which is this type class for graphs, but I think we should be able to maybe, so let's write it here, and it's from a T, which is a graph, so it's probably just our graph, to a G graph for A. So when we say but no, because it needs to be specifically for relations, which we succeeded in compiling, and I think yes, since all of these are subsets, having a type class will obviously be really helpful. But for the sake of just having a directed graph right now, we'll just do it as relation to G graphs. Yes. And we'll implement that. How? Now we can try for G, which is going to be for G from a graph A. So that's not going to work. We're going to need the for G for relation. Okay. So let's get that. And I think it is the symmetric one, right? Yes. And so fold G is not here. Yeah, because it's going to be in the relation. But hold on, yeah, it should exist. Fold G. Oh, hold on. So it has defaults. Is that right? This uses 4G and 4G uses 2Graph as well. We get a graph, we pass it, make it a relation. How did we define this already? So hold on, we had both relation and relation symmetric. We did. Okay, so maybe actually I wasn't looking at the right thing. Here, let's just have a fold G. It does not. Is that because the instances of 2Graph are in 2Graph? Where are the instances? Yes, indeed. That's why. So what's the 2Graph instance? Yeah, so there's defaults there. So 2Graph is defined for relation, but not for G. So it means that in that case, we use the 4G description based on 2Graph for relations. Okay, well, I mean, that is going to be actually tricky to do in Purescript. You're going to need defaults and whatnot, but okay. So what did we say? We said we can define 2Graph for relations. We have 2Graph for relations, and that's this. And so we'll try that. G being simple graphs, right? Yes. So that's fine. And so that's, yeah, I mean, actually, does this compile? We need to import relations. And then do we have that? We don't have a to list. What does, so vertices do take lists. And a domain in relation is a set. So we do want to go from set to lists, and I think that's just from list, isn't it? No, I mean from foldable. Let's see if we have something similar in this neighborhood. Okay, if it was somewhere, it would be here. or maybe in the adjacency map. Set member. Okay, let's use pursuit. Apparently not in my, oh yeah, because of the what are we saying? Yeah, set A to list A to unfoldable. Okay, let's try this. To graph would have to unfoldable from data set. Okay, so set to unfoldable. Bingo. What's the problem with our domain? Yes, it's going to be r.domain. And then here to unfoldable and r.relation. And we don't have an R because we didn't watch closely enough. And relation, it's into graph and to graph R. And it compiles. And hold on, I thought I had a to relation. Oh, I see. Yeah, that makes sense. So the fold G that we want here will be actually, yeah, that's a good point. It no, it will be the 4G for graph. Yes, I think. Let's look again. 4G for graph will give us a B. And yeah, we pass it relations, so we get relations. So we just want to make sure we're yeah, we're not doing that. That's not good. Okay, better. And here we can continue our little transformations. UG dot connect. Okay. And pattern matching. How are we going to do pattern matching? We are pattern matching on the last thing there, so the fifth argument. So 1, 2, 3, 4, 5. So the graph A. So that's the local graph. And don't we have? Ah, yeah, we just need to wrap it inside UG and that's it. Or pattern match to the yeah, the UG GMT. Does this make sense? Yeah, I think so. UG G vertex X. Maybe the parentheses are going to not be happy there. G overlay XY, probably same problem. And UG. Maybe you could unwrap underscore there. But we'll see. Yeah, no, it seems to maybe work. So UD and empty here, empty. We actually probably only need. Do we even need them? I tend to be fairly zealous with the parentheses, but sometimes I might be wrong. Especially with this, I think maybe this this particular syntax is actually more forgiving than the pattern matching in a function body, a function left-hand side. But it could also be that it's because it's a different pass of the type checker. Okay. Yeah, right. So that needs it. Okay, you know what? I'm usually good at spotting these, but right now I wasn't. Okay, that's good. And okay, I like this. UDT Vertex, those are all, I think, actually those are not UG ones, just G ones. So that's pretty good. One more empty. Those should be also exactly the same ones. Just a few more. Well, yeah, actually, that's probably not going to type check. That's probably just not going to type check. But that's okay. We're getting closer to actually have proper type checking out this mess. And there we go. Okay. That's probably what we want here. And type variable A is undefined. So indeed we have new things because we're in a different phase of the type checker. We're starting from a relation R. Oh, we might need to unpack it. Yeah. Woohoo. And yes, okay. So I believe that should be, yes, that is good enough. So that's just a tiny bit better than I think in function left-hand side definition. Except that apparently we are not good. Why is that? We take two graphs. So we take two graphs which are our local graphs, right? There are UG prefix graphs. And could this be a new type? It couldn't because of the instance is. And couldn't match type graph with graph. That's a little bit annoying, but it could be because it's local graph from and a compared to a non-local graph. So I mean, first of all, we could just map UG here. Couldn't we? We could, but apparently that wouldn't make this happy. But overlay takes a graph and oh, right, it doesn't. It takes a UG of x0 and a UG of y0. And the vertex, however, takes an A, so we're good with that. Oh, that's a lot of. I think I could probably make this much prettier if I knew my wrapping, unwrapping better. Let's look at alga. Undirected people. Where are our undirected people? UD blah. There's a whole bunch of cores here. And what are we looking at? Structural equality. Structural, okay. Definitely not that. Oh, actually not something that exists apparently here. EQR that converts to symmetric relations. Interesting. Why? Why don't we have the equality that's mentioned here? Is that just because I copy pasted from here, didn't I? Whoopsie. I did. So this structural equality, is that something new that Thomas built? It is a triple equal. So it does exist on regular graphs. Does it not exist on undirected graphs? That would be quite weird. But it is the case. How interesting. Well, I don't know that we should let that distract us from trying to implement it. I think there's at least 4G that we want to implement. And 4G though would be defined in the toGraph thingy for undirected graphs, but is that the case though? I don't see 4G for undirected graphs. Could it be that there's way less things for undirected graphs? Fold G? No, there is. It's there. So that That's to graph. That's okay. So let's get the source here, and let's get to fold G. Fold G is just chorus G fold with a specific chorus. Could I just use chorus too? Would that be even faster? Let's look at Purescript chorus. Save zero cost coercions. That sounds attractive. Seems to work for new types. So I think that's what we want. Let's Bago install save course. Except it doesn't exist apparently. Kidoki. Let's add it. And with safe course equals things. Repo. Version and dependencies. And the version, it's equal, isn't it? Version will be like, well, let's pick v100 and go check out what's in there. And we have, oh, it depends on unsafe course, and that's it. That's nice and clean. And git add foo. Trying to use a URL that okay, yeah, it can, but it won't. We'll use the HTTP URL instead. And that should make all better. Yes, it does. And then we can just use chorus in lieu of all the things, probably including all of that, especially if we import it. GMT though. Yeah, looks like we absolutely could. So like so, right? Or maybe like so. Or like so. No. So it doesn't work in this direction for some reason. Chorus of the new type thing equals, right? But chorus in Haskell works different. There's a chorus 00 apparently. What is that? Oh, it's to help type inference. Oh my. So maybe that's exactly what's missing there too. Well, oh boy. Can't say that I like that. Let's see whether chorus G fold is just going to work for us or not. Chorus G fold G. Well, we don't know, but we can try with structural equality from well, XY, I suppose. Or just this. How about that? Yeah, no, that's not going to work. And so I suppose we're going to have the same problem, and it is a type thing. Okay, so that's, but this is just chorus though. Oh, no, but hold on, look at that. Holy moly. Okay. Apparently that's to help the type inference. So let's call this chorus prime and use this as chorus prime. And we need to follow quite a bit. Oh, actually just AB apparently. But that's not enough. Yeah, maybe because we need to actually unpack our things. In which case X and G will be operating on a G dot graph. And oh no, it will return a G dot graph. Yeah, so maybe that should work. I'm not clear about all this, but yeah, I think I've been droning on for way too long. Let's just wrap up. Where are we at? We've implemented some more tests, so that's good, and we're still implementing undirected graphs. Yeah, what are we doing specifically? We're doing fold G and chorus. So we'll do more of that next time, and yeah, carry on with trying to do a Comonad for our undirected focus graph, and then maybe understanding what that means for directed focus graph. It's probably going to be similar, but as we do that, we build up Purescript alga, which is always nice. All right, so thanks a lot for watching. Oh, my camera had gone AWOL, so we'll fix that just to say bye-bye. Maybe. Depends if the GoPro wants to restart or not. Looks like maybe it did, but that's not enough to get the camera back, but that's fine. See you on Saturday for more graphs and Comonads. Bye-bye.